Rahul Dada, can you hear me? I hope you can hear me, and I will share my screen and start explaining to you. I hope it is recording. And if you face any network issues, please let me know, because I will continue until I will show you how this mesh motion is happening. So you can see my screen, right?
Yes.
So everyone can see my screen. Let me see what. Okay. So this is what the case file is, the tandem wing folder, not the case file. This is the tandem wing folder where I keep, this is from just a tutorial point of view. This is the case file of one of our senior. And here is the tandem wing, and this is a project file, and these are few case code files, the C files for mesh motion, in which you write the motion of your airfoil. And these are all the things, whatever these folders and these names. So this is what the tandem wing project file. So first of all, what you have to do is you should separate your case file in this project file. Where you can find your case file from this project file is whatever the name you give for your tandem, for your project file, that is tandem wing 01. The same name will be created with some folder, to some folder that is called tandem wing 01 files. So close your workbench and go to this folder tandem wing 01 files, and go to DPO and go to FFF and go to Fluent. Here you can find this FFF.1 setup output.case. This file you can find only after uh, you generate your case file successfully, and only after you can give your inputs everything correctly. So this file will be automatically saved here, that is FFF.setup.1. So copy this file. Copy this
Durga,
file from, yeah.
sorry for the distance. Durga wants to want you to adding. Try. Yeah.
I'm doing it. He can join directly.
Should I tell him then? He called me to tell. Okay.
Okay, you can also add him directly. I'm calling him also.
Okay.
Okay. Can you see my screen? Rahul Dada, is it okay just for only for tutorial purpose I'm showing this your case file? I forgot to ask. If not, I will share mine. Hello? Rahul Dada, are you there?
Yeah, hello.
Yeah, is it okay just for tutorial purpose I'm showing you your case file, how to compile your code?
Yeah, sure.
Okay. Okay, thank you, Dada. So you can see my screen, I hope. So now copy this case file from this location. Just copy it and place it some random folder wherever you want. So I'm placing it in some TW2 folder, some empty folder. Okay, just copy that and place it in out of the that project folder. So I'm placing that case file here, and here is the code file in the sense, if we open this code file, you can see some libraries and you can see motion of your airfoil. You should write your motion clearly, the values and those kinematics clearly here. And how you can write this syntaxes, you can follow the guide of ANSYS Fluent customization, or ANSYS Fluent some UDF tutorials, not tutorials, some manual is there how to manage these all things. So you can follow those things and you can write this. If you want to know these some of the key things, we will discuss those things later. So this is the file. Now what we are seeing in this tutorial is only how to compile this in ANSYS Fluent, so that we can apply it for our present simulation. So this is the code file. We should load into our environment of ANSYS Fluent, and then we have to compile it. Then only we can apply it for our simulations. So this is the case file and this is the code file. So after placing these two things in your separate folder, please remember that this folder should be separate from the your project folder. Tandem Wing is your project folder and TW2 is a separate folder where we are working now. So copy these two files and now go to your, before going this, you should have your Visual Studio installed in your system. So Visual Studio should be there. Visual Studio installer, whatever the Visual Studio software libraries, all things should be there in your system. So just install it and we don't need to open anything as a Visual Studio interface, but we need the developer command of the Visual Studio. So it is the developer command prompt. Mine is 2019. So please check your versions also. If you are using 18.1 or 18.2 of ANSYS, then please check the corresponding Visual Studio version. If you are using 18.1, maybe 2017 or 2015 Visual Studio should be necessary to compile your code correctly. So mine is ANSYS 2020 R1. So I can use this Visual Studio 2019 version command prompt. So I will click it and it will open. Now what I have to do is I have to open the ANSYS Fluent program from this Visual Studio command prompt. How you can open means, first you should locate where is your ANSYS Fluent program installed in your system. For that purpose you can search it Fluent here and you can right click and go to the open file location. So if you go to your open file location, it will again show you one shortcut key, and you can, if you click open, right click again, and if you click open file location again, you can see where it is. It is here. This is the corresponding Fluent .exe applications, and it is executable application. You can find it in your my local disk and program files, ANSYS Fluent version 201 Fluent NTV and Windows 64. What you can do is here you can directly copy this path, or for your understanding I will type this path here. So what you should do is cd, that indicates the chain directory, and c is the local directory, and I will type program files. So cd c program files and click enter. Now you are in the program files directory, and change the directory to until you get Windows 64, I mean Win64. So use the cd command and change the directory always, like ANSYS incorporation, like cd version 201, or you can type entire things at the same time, and cd Fluent, cd nt bin. If you are okay with that, you can type enter command prompt at yourself, or you can copy the path also. You can paste it here. Just for your understanding, and typing the path for every each and folder like this. So now you are in Win64 folder in this command prompt. And now you can directly type the Fluent. Just enter the Fluent and it will open this panel. Okay. So this is your launch startup window, Fluent startup window, and it is now running from the environment of Visual Studio command prompt. What you have to do is you must select the same folder here, working folder. This working folder should be same as your TW2 folder, what I have shown already. Let me open this TW2 folder. Yes, you should select your TW2 folder here. So for that you should rename it. Where my TW2 folder is, the ANSYS and tutorials and Tandem Wing and TW2. This is my working folder now. So I will select that folder, and it is a 2D model, not a 3D model. So I must be very careful here. 2D model, double precision. So I should check the number of processors and GPU, all those things. And my working folder is TW2. That is also okay set. And you can go for start. This will launch your Fluent window where you can now work further. So what you can do here is let it load. Okay. Okay, it is now running. So what you can do is you can directly read your case file here from now. Go to the file and read and case. Okay. So our present task is not to, if you click on that read case, you can click on it and click OK. After that, you can directly load your case file. But our present task is not to load this case file. If it is the thing, and we can load the case file also. But let me show you first how we compile the any code without loading the case file. Also, we can compile the any code just for creating the UDF files. So here you have the option user define. So I hope you all can listen me, right?
Yeah, yeah, it's
Okay, fine. So now here you have the user defined tab, then go to the functions, click on this drop down arrow. So you can find the interpreted, compiled and managed. So click on the compiled option. There you can find the add button. So click on the add button and you can see here directly it is showing the working directory TW2. So working directory TW, because we already selected this is our working directory, and you can see it is showing the flap.c as our code. So click on the flap.c code and click OK. So after clicking OK, what you should do is click on the build button. Click on the build button and it is showing a warning. Make sure all the directories contains in the same folder. Your working directory should be set correctly and there should be your code file also. So all the directories are correct because we are not working on different directory. We are working in the same directory. So click OK. So whether it is working or not, let's wait. Okay, it's just compile. Let's see for any errors or not. If you find any error here, that means your code is not compiled successfully. So you can check here. Is there any error here? I find no error. So code compiled successfully. If another thing is after successful compilation of your code, you can find in this TW2 folder, you can find this libudf folder, which we creates by this ANSYS Fluent application. That actually libudf folder is something like a separate folder that helpful for managing the mesh motion, even if you don't compile the code for later versions of not later versions or different systems. You don't need to compile the code again in different systems of the same version. You can use directly the same libudf folder. That is the use of it, and it will all the mesh motion details are available in this libudf folder only. So if the same versions only, don't use for different versions. If it is the version is same, so that you can use this libudf folder in other systems also for the same kind of mesh motion. So now our code is compiled successfully and libudf is created. Okay. Before loading using this load button, let me load the case file. Go to the file, read and click on the case file. Now I will load my case file here. So it will load all the details available. We no need to do anything here. All these errors are actually showing because of while creating this case file itself, we tried to make this mesh. We tried to include this libudf folder. So it will try to load the libudf from the previous paths. We changed the paths. We are not using the old paths. So these errors we can ignore here because this is not your current focus. So this is your domain and these are your airfoils. And let's not worry about all the details. So this is a triangular mesh. So you can work on your triangular mesh only is possible for the dynamic mesh, and remeshing also is only possible for the triangular mesh. So after doing this, what you can do is you should load your libudf file. Where you can load your libudf file, go to again the user defined and go to the functions, and you can find the compile here and just click on this load button. What this load button do is it will load the libudf folder what created in the TW2. You can see in this console it is trying to load the libudf, and now it is successfully loaded. And look at your code name. The name is the indicates for your as a variable for your motion, like you are describing your motion with a name called shma. Okay, this is the important name for your name of a motion that you can understand like that. And if you could check on the dynamic mesh just to check whether the motion is working or not, go to the dynamic mesh And you have here options like click already selected dynamic mesh, smoothing and remeshing. I'm not going in details of settings of this dynamic mesh, smoothing and remeshing. You can work those things later on your own. And how to create, whether it is working or not, I mean more mesh is working or not, go to the create or edit, click on create or edit, and you can select the domains. Airfoil 1 is maybe first airfoil, so you can check the airfoil 1 and select it as a rigid body option. And here in the drop down you can find shma. This is the name of your motion, shma lib udf. And center of gravity, Rahul, can you suggest the center of gravity locations of this code? What is the center of gravity of airfoil 1? Any points that I should mention here?
First one, no?
Yeah, first airfoil.
Minus 0 and y is 0,
0, 0?
0.03 minus 0.
0.03 and
This is 0.04.
0.04. What does these locations means? You can find, fix your location.
Yeah, it is the center of this.
Yeah, these are the center of gravity or pitching location, whether you can fix your at your required point. So these are the points that are corresponding to the airfoil 1. So, and then I will click on create button. So now now what we just did is we are instructing the Fluent software to create this kind of motion. What is the motion means? That was motion named as shma, and all the instructions you have already given in your shma folder. And because it is a triangular mesh, remeshing is possible. Okay. And there is inflation also around your airfoil. So let's see whether it is happening or not. If it is not happening or anything, a few errors, even if it is showing errors, it is important for you to learn, because even if you are doing later on times, errors like negative volumes or very less orthogonality, those kind of errors will stop your dynamic motion. So we should be very careful. And it is just for tutorial purpose. It may give you motion or it may give you some error also. Just to see whether it is performing well or not, click on this preview mesh motion. You can see here preview mesh motion. So click on the preview mesh motion and you can select the time step as you wish. I will try to select a 0.1 and I will try to use the number of time step as 10. Okay. And display mesh. So let me yes.
You selected mesh zone as airfoil. So does that mean like, so how, what is the influence on the meshing for like on this selection? Because we wanted to move only the airfoil, but how does the mesh change? Does it change or what exactly is the influence?
Mesh stretches. Mesh will stretch at those locations. Mesh will compress at opposite locations. Wherever the airfoil is moving, mesh stretching and compression and reforming of the mesh will also happen. That is called the remeshing.
So okay.
So
So for us, we need to generally select only airfoil, or are there like in some cases we need to select the zone as meshing zone also?
that those things for sliding meshes, offset kind of meshes, for those kind of things, we need to select the zones. For remeshing
Okay,
kind
it
of
depends on
things,
the problem.
depends upon the problem and depends upon the type of meshing we are using. It is a triangular mesh, so remeshing is possible here. If it is a hexahedral mesh, remeshing is not possible. Or if it is structured quadrilateral, also remeshing is not possible. So then we should use the offset mesh or some sliding mesh, those kind of things. I hope
Okay.
cleared your question. Okay, so let's try whether it is happening or not. After clicking the preview, sometimes your display may gone. It may not show. Yeah, here it is showing negative volumes. That's what I said. Negative volumes are detected. That means one of the problem may be this is the inflation is the structured inflation. I mean, these are quadrilateral cells structured around the things. These cells are not permitted to remesh. Only the I mean triangular mesh are allowed to permitted to remesh. So either we should modify these quadrilateral cells into triangular cells so that can you can perform the remeshing. I mean, you can perform mesh motion. So this is the one problem you generally face when you're trying to do mesh motion with this triangular elements. So if your case file is perfect and you are doing for some other kind of mesh simulations, not like some other kind of, for when your dynamic mesh is successfully running, what will happen is, let me show you the some examples. Yeah. So if your mesh motion or everything is okay, then this is how it looks like. I hope you can see you can see the moving mesh, right? This is some kind of airfoil and it is some moving mesh thing, and it is same dynamic mesh principle only, but it is following some other different technique that is called overset. So you can also learn overset. I will try to find those videos also later. So Rahul Dada, I hope I cleared your queries and everything, right?
There is some with that part that you pointed out.
Which one?
The inflation part. Inflation is there, no? Very volume.
Inflation. Yes, Dada. Inflation is okay, but the thing is,
There should be a triangular section or something.
yeah, these cells should be also triangular. There should be no inflation, but cell size should be smaller. Then I think it can remesh. Or you can contact Jidda. Jidda uses a layering technique. He uses a structured mesh only. I'm not sure, very sure about those structure. He used structural quadrilateral cells only, but he used layering and remeshing, so that layers will stretch and compress. I mean, so that motion will happen. Layering is also there, but I'm not sure how to use it.
We'll just go for the triangular part. I got the same error, I think.
Yeah, it is the negative cell volume detector. Negative cell volume in the sense cells are merging, or I can say overlapping simply.
I tried to load that part with. I will do it with the command. Okay. If I get any error, right now I'm using Visual Studio 22 version 2022.
Okay, Dada.
It will go for with 18 19.2 will work or not. Any idea you have?
Like I have this experience. 21, 22 was not working with this 19.
Okay, okay. And which version you are using? Visual Studio.
Sandeep,
Latest. Yeah, initially, firstly, I installed the latest version 21.
Yeah,
It didn't work well with the 19 ANSYS.
then we should go for the older version, no?
Older version. Mine, then Ganga suggested me to use 17, and then it worked.
Okay, 17 was working, no? Okay.
Yeah, 17 was working with 19. Yeah, it
Visual
was.
Studio Professional or some that.
There's something called community, I guess, right? Community or something. That
Visual
was
Studio installer is sufficient, Dada. Just install
actually installer is sufficient.
Visual Studio.
But actually to download, they ask whether it's professional or community one. I used community one, I guess. Yes, I can let you know later exactly what.
Okay. I think I need to check it with the Visual Studio. I have 22 version.
Yeah, 22, right? 22 is the latest one, right?
Yeah, yeah.
Yeah, 22